Sorry. So you can put whatever imagination you have in your mind to that piece of paper, right? So that's what we can do with the digital representation of this canvas in HTML5. Okay. So of course it is part of HTML5 specification. Um, so a canvas is actually part of DOM, but the object whatever we are going to add in it, draw in it, is not part of DOM. So can you get what I'm trying to say here? So it's basically an image as an image. So let me show you an example first.
Just in case you forgot what you said, he is reminding you.
Thanks. Okay, cool. Let's go ahead. So this is basically okay. Probably I can show you the code first. Like I said, this is more of a practical than a theoretical one. Yeah.
Font size.
Sure. Yeah. So to start with, we have a basic HTML file which has a single element, the most important element in it, which is canvas, of course, here, as you can see. So the beauty of canvas is the canvas element itself is nothing. It just occupies a space in the DOM, that's all. So whatever you want to draw in the canvas, you have to do with the help of Canvas API, which is developed using JavaScript, provided in JavaScript. Let's get into the JavaScript part. Okay. So what are we doing here? So if I want to, so this is basically a canvas. I am rendering a simple image in this canvas. So if you want to convert that image into a negative, so basically let's not even talk about canvas. So what would you do if you want to make a convert an image into a negative of it? See how this is implemented in canvas. And then at the same time, what would you do if you want to turn a colored image into a black and white version of it? The same principle, exactly. So you just need to take the average of RGB and then assign the values to all the three colors. Simple. So we're doing it here. Fine. So let's get into the code part of it to see why canvas is considered as a bitmap image. So basically, so this is the code. Everyone able to see this, or do you want me to? Okay. So basically, this is the code, the simple piece of code that we are using to convert colored image into black and white. So what we are doing here is simply get the image data of the canvas, and then it will basically return you the array. If you can see this, maybe we can play around with it. Plus, first understand the no code part. It will simply give you the array. So the array is nothing but the collection of the pixel information. It's a single dimensional array. So the way that it is structured is like this. So let's say the image data holds the entire the pixels of the canvas. So it's a single dimensional array again. The first four elements contain the information about the first pixel. So basically the first element contains a red value, second element contains green, blue, and then alpha, and then it goes so on, like that. So all we are doing in the code is to simply loop through the array, interleaving by four elements, and then get the red RGB value, take the average, assign it to all RGB value. This is what we are doing to convert the image to black and white. Cool?
Yeah, so
yeah.
What is get image data is actually reading that image and converting it into an array.
Bitmap array, yeah, of course, yeah. So bitmap is basically, it represents each and every pixel, right? So that's what it does. The same way as you said, so if you want to turn the image into negative, you just simply need to invert the colors, like 255 minus. Of course, every color is represented by an 8-bit value, which can take up to 255. So we just need to minus it by 255 to get the value. That's all. So it's a simple way to understand how the canvas work. Okay, so let's move on. Any questions so far?
So any image I can put it into a canvas and I will be able to get.
Yeah, any image. So that's, yeah. So basically canvas itself is an image. So you can actually save the canvas. If you go to Chrome and render the canvas, right click, you can get an option to save it as an image. Simple.
What context object JavaScript?
Yeah, yeah. We'll come to that. When we try to write the game, we'll come to that. Good. Okay, so it is faster, of course. So what are the other alternatives we have to draw graphics using JavaScript? Of course, we have SVG.
WebGL.
WebGL. So basically, Canvas is a kind of it depends on WebGL.
The Canvas is a 2D API, whereas WebGL allows for
3D. So there is a specification which is already part of Canvas, which relies on WebGL. So it is yet to be implemented by other browsers. It's good. So yeah, so compared to SVG, this is faster. Why? Anyone can answer this question?
Is it because it's part of the object model?
Exactly.
Right?
Yeah. So if you take SVG, so for people who don't know what SVG is, it's again a graphical. It's a tool. It's a library, whatever you can call it. It's a markup language you can use to draw graphics in the browser. So basically, what you have to do instead of writing it in an image, you have to create a DOM element like a rectangle, circle, path, whatever, and it will take its own place in the DOM. So basically, if you're going to create, for example, 100 or 1000 nodes in a browser, it will be part of the DOM. So anything that is part of the DOM will recover the traversal of the DOM in order to manipulate it. So that will take more time. But whereas this is nothing but a single image, canvas. So just have to manipulate it. Nothing is stored in the memory, so everything is faster. There is no need to traverse. Right. Okay. Why it is faster? Again, so these are the three important points that we can say. The first is it offers only low-level API. So if you take it's a DOM or a basic JavaScript that the browser offers, so you can have the event handling like clicks. And you can even there are data manipulation or selection APIs that is available to select the DOM elements. Everything is available out of the box, off the shelf. But whereas when it comes to Canvas, nothing is available. It's an image. You have to write. You have to keep track of the object, whatever you are going to put into that image. So this is how it works. It offers only a low-level APIs to try a rectangle, path, or do some physics, mathematical operations on it. That's all. You have to keep track of everything in memory, and it's all up to you to make it the logic. Of course, there is no DOM element. There is only one DOM element, which is Canvas, and then no event handlers as we discussed. Good. Okay. Now, so coming to the most important part of the talk. So the 4 easy steps to write an image using Canvas. It's simple. You just have to identify the objects, whatever objects you're going to have in the game. We'll see that. And then keep track of the object's shape and positions, probably in the main memory stored in JavaScript. And then paint the objects in Canvas manually using the whatever low-level API that it can offer. And repaint the objects in a regular interval. Basically, people used to have set interval. So you know how every video, or it's nothing but a sequence of images, right? A video. So just basically how to draw the image each and every frame. So this is how you have to. This is how you can write a game in Canvas. So any question, because we're going to move to the practical part of the game.
I think point number 4, if you can show it.
Yeah, I'll show.
Because that is something to do with request animation.
Yeah, exactly. Okay. So what we can do for the next maybe 20 minutes so I have a skeleton of the game that I've created. So it has some basic code written in it, of course very basic. And then the key part of the game we are going to write together. Fine. And again, stop me if you want to know more about it, any particular step you first start. Let me go through the first step is to identify the objects. So what are the objects we have? So this is the game we are going to develop. The first object we are going to write is a friend tree. Okay, before that a question. So when you travel in a train, when you see outside through a window, how do you perceive the image? So basically what happens? The object at the front will move faster, the object at the back will move slower. Right? So if you want to create that illusion in Canvas, there is a trick, a simple trick. We'll see that we'll see how to do that.
It's called parallax.
Exactly. It's called parallax. Parallax. So what are the images available in our screen? The first is front tree and then back tree. Sky, the runner, grass, and the bomb. So we'll have to create object for that. So and to create the parallax illusion, whatever we discussed, so we are going to move the first layer of the tree faster, and then we are going to move the second layer of the tree slower compared to the first layer, and the sky will be the slowest object that will be moving. Fine? Good. So this is the skeleton that we have. Before that, let me open the HTML. Show it. So this is all we have in HTML part. As I said, Canvas is just a simple DOM object. It has nothing to do with the logic, the element itself. So we have one simple div, and inside that we have Canvas. That's all. So what are the objects that we identified? These are the objects that we identified. So before that, so to people who are new to JavaScript, so this is basically what we are doing. The first line is to get the Canvas element and store it as a reference in JavaScript. And then, of course, this is the context, 2D context. So Canvas offers two types of context. One is 2D and then one is 3D. When I say 2D, it basically gives you the API to write, create, draw triangles, all that two-dimensional objects into it. So we are going to get the context. So everything, every API that we need exists in that variable now, the context. And these are the images, of course. So everything that we saw in the game is an image. Even the person who's running that game is a collection of images, which we call as sprite. And then we will come to this variable that. So these are the images that we are going to use to create the screen, to create the game. Probably let me show the. So this is how it's basically a PNG version of it. So we have small tree, front tree, and then grass, sky, bomb, and then runner. So basically, so when you have to make make any object move in the canvas, so it has a velocity attached to it. So as we said, we're going to create multiple layers to create the illusion of parallax. So we're going to attach different velocity to different layers. Right? Any questions so far? Right. Yeah.
Sprites is individual images which you use to represent.
Sprite, yeah. I'll show it. Yeah. Let me show it. So this basically has, yeah.
This is called a sprite sheet.
That's sprite sheet. Sprite sheet. So it basically has a different actions movement that the runner or the object can perform. So we're going to assign different velocities to the different layers, crash, friend, and all, as we talked earlier. And then offset. Why we are going to need offset? So we have to make the objects move. So basically, if you go back to the illusion, what happens here? The user is still running in the same place. We're going to move the background backwards so that it creates an illusion of the person running in it. So that's what we're going to do here. So every layer has an offset attached to it. So which will be used to move the layer backwards. Okay. So this is the skeleton again. We'll write the code. This are the function used to draw different objects: sky, trees, bombs, and grasses. And then this is the actual runner object. Why do we have this kind of position, the collection of position? We'll talk about it again. So this is the basic. So when you the key that we are going to use to make the player jump is the up key, up arrow. The key code for that is 38. It's a simple thing. And then there is one function again, as I said. So we will have to call the draw function again and again. We'll have to define each and every frame, draw each and every frame. So there are multiple options to do it in JavaScript. We may use set timeout and call it again and again. We can use set interval. But why are we using request animation frame here?
There's no overhead on it, right?
Exactly. Yeah, close to that.
Yeah.
So the thing is, so set interval itself has its own overhead. So the what request animation frame does is, so whenever the browser repaints the window, the canvas, so it will, so whatever function, the callback you're going to pass to the request animation frame, it is part of the browser API itself. So this will be called. So what it actually wants us to do is to, you keep track of the object, update all the position shape of the object, and then when I want to refresh the image, I will call this, update it, I'll redraw it. So this is what's going to happen. The perfect synchronization is going to happen with the help of this request animation frame. So otherwise, if you're going to use a set interval, at some point in time, it will go out of sync. Good. So at present, so there is nothing. We will start drawing objects one by one. First, let me save the context of the. Let me save the context. So when you save the context, what happens behind the hood is, so every property, the global property values that you set to a context, for example, line width or the new position of the axis x and y, everything will be saved so that you can restore it at the later point in time. Fine. So now what we have to do? So we have a velocity and then offset. For every frame, we have to move the background objects backward. So that what we are going to do is simply, so for sky, get offset, and then for sky we have velocity set. So what is it doing? So basically it will call the function, this function get offset. So what it does is it will check whether the offset is going beyond the boundary. If it is going beyond the boundary, it's going to set it to 0. So that we will get the illusion of the object moving in the same place. Right? So now we have the offset in hand. So there are two options available to it. Either we can update the position of the objects in hand. Otherwise, you can shift the axis of the canvas itself using context.translate. Okay, so why are we doing this? Let me. So this is what the translate function does. So basically, so the way the axis is defined in Canvas is different with the real world. So when you take a conventional graph, your x-axis is drawn here, y-axis is drawn here. But here it is, everything is inverted. So what the translate function does is basically to shift the x and y-axis to whatever value you are going to give. So what I'm trying to do is, I'm going to shift the x value to whatever offset. So which means shift the base of the canvas here to here. So whatever new coordinates I'm going to give will be updated, but the canvas will be moving in the backward direction. Fine? We'll see it. So now it is updated. So let's draw the image, which is nothing but sky. Image. The draw image takes 3 parameters. First is the image object itself, and then the second and third are the x and y respectively, x and y coordinates. So draw image. So what we have to do now is to create the continuous the illusion of so the canvas moving backwards, we'll have to draw the image twice. One starts from the zero position and one start when the first image is going to end. So dot with, let's say -2, 0. To restore. Okay, let's see what we have. Just a minute. Yeah. So to see it, basically we are drawing the same image continuously twice. So at the same time, we're going to update the translate the x-axis to left for every call to the function. When it comes to goes beyond the boundary, we're going to reset it to 0. Any questions?
So you are drawing an image. You are drawing the same image again twice.
Yeah.
You are not drawing it again third time.
No.
2 times.
Because we're going to reset it when it moves when the offset goes out of the boundary.
And
Left
when you are
boundary.
moving the canvas, it's like moving the camera when you are looking at the screen.
Yeah.
You are not moving the screen itself. You are moving the.
Exactly. The camera goes out of the left boundary. We're going to reset the camera to the position.
So that's you're basically moving the camera back and forth, back and forth, back and forth on the same image. But
Yeah.
the image itself is not moving.
The canvas is moving.
The canvas is moving, and you've got 2 images side by side.
Yeah.
So if you think of it like that, it makes kind of sense. Like, okay, you're moving the camera back and forth, back and forth.
Exactly. Okay.
And why is that -2 you put? What is that -2 value?
So if you're going to put it as a positive value, it's going to move it to a right direction. -2 basically any minus value will move the canvas to the left direction. That's right.
Then just change it and show it.
Yeah.
No, not that one. The 2 lines down. Try image.
Oh, so okay. So this is just to create the continuous illusion. If I'm going to give it, there might be a gap in between the images.
So how did you pick 2 then?
It's a random value.
It's a
You can
random
do you can give whatever value you want. That's 100%.
Can you see that line? Just show that. There's a little line, right?
Yeah.
That vertical line.
Oh.
So to merge it, you are just overlapping it.
Overlapping a little bit. So you're saying like 2 pixels overlap. That 2 is for a pixel value.
It could be anything, just to make sure that there is no gap in between 2 images. It could be anything. Okay. In the same way, we are going to draw different objects. So the tree, for tree, we are going to make it move faster than the sky. Velocity. Just need to give various positions. For example, I want to draw the tree at y-axis 240. Maybe it could start from 200. The same principle has to be followed here to make the continuous motion. So whatever object you have to draw, you have to write the second frame of it. So let me draw 4 or 5 trees. If you can observe closely, the tree is moving faster than the sky, giving you that parallax illusion. Okay, let's go ahead and draw the different things. The front tree, again it has a velocity attached to it. So we can make the tree interleave with the back tree. So I'm going to give 50, 900, 1900, and probably add 220. Fine. The same way, grass. Grass velocity. So we're going to have two grass images drawn continuously back to back. So which starts with 0. The height is basically the width, height of the canvas minus height of the grass image. So width minus 2 or 5, you can do whatever value again. So now we have a background drawn. So any questions or anything that have?
What is offset?
Okay, so again, so we have to move the objects backwards, right? So on every, so obviously the draw function will be called whenever the browser re-renders the animation, the frame. So we have to move the object backwards. So in order to do that, we are going to update the value, the position of the canvas. It's like adding a value to the x and y coordinate. Offset is nothing but, so for example, if it's going to be 0 here, if you give -2, it will come here. And then whatever you draw at this place will come here. So it will create the illusion of moving, right? Fine. So and then we have a velocity to control it. For example, if I want to move it, make it move faster, let's say 10.5, it will move faster.
Also, why does the tree disappear like every second?
That's again, so it has, we have to be specific, accurate in whatever value we're going to give it. So obviously we're not. This is what you're asking, right?
Yeah, the tree just
Yeah,
totally
that's flickering
disappears.
effect. We can do it, but it requires more time. So.
Yeah.
Okay, getting back to. So the next part is to make the player run. So now, why do we have these running positions?
The base.
Exactly. So each and every position. So obviously, if you have to make the object run, you have to continuously render the image, right, on each and every frame. So this position is carefully calculated based on the sprite image we have. I'll show it. So this is the image we have. So whatever action you want the player to perform, you can add it. Even you can punch, you can do whatever you want. All you have to do is to make sure that the action is part of this image and you know the position.
But how do you transition from one action to another?
Yeah, we'll do this. So right now we are going to make the user run, which is at the third row, and then we are going to make the user jump. So if you see, these are the positions corresponding to the third row, and this is the jumping position, which are corresponding to the second row. Okay. So these are the parameters that we can use. We'll see while we are using it. So now we are going to write operation to run. So basically, what we have to do. So as you can see here, on every rendering of the frame, the draw function, animate function will be called with the time. The time is basically in microseconds, and then it will in turn call draw. It will call again all the objects draw functions. So we can see here, this is a function which we're going to use to draw the player to make the player run and jump. So it will call the function run. So we are back again. The first thing that we have to do is to identify the right position for the player's action to make him run. So we have an index for that, run position index. So now, if the index, so what we have to do on every frame, we just need to increment the index, right? So that the user can move. If the index is greater than or equal to the run position dot length, to make sure it is not going out of the value, set it to 0. Come back to the first action position. Otherwise, simply increment it. Now, take the position. Simply assign it to some value to make it easy. Get the updated index. Now draw. This dot context dot draw image. So here we are going to use a specialized version of draw image. So what we are going to do is, so now we have two images. Again, canvas is an image by itself. So we have two images. One is sprite, one is canvas. So one is source and other is a destination. So we have the coordinates for the respective position in the sprite. So what we have to do is make use of this overloaded version of draw image. So the second, and the third argument corresponds to the x and y coordinate of the image within the sprite sheet. And then SW and SH corresponds to the width and height. So basically it goes on like that. So run the image, another image. Position dot left, top, and then position dot width, position dot height. So right now, so far what we have done is to pick the respective part of this image, the first position of the image. Now we are going to draw it in canvas. Give the coordinates for that. So maybe let's say we are going to put the runner 20 pixel from the left. The left margin is defined at 20 pixel. And then 20 pixel above the bottom. Height. Finally, position dot width, height. So, now if you see here, you can observe one abnormal thing. The user is running so fast. So why is it happening?
You are painting the entire.
Exactly.
Refresh rate.
Exactly. For example, a typical browser could have refresh rate more than 30 or close to 60 frames per second. To control it, what we are going to do is we're going to have an interval. At the same time, we're going to store the time. So as I said, every time when the request animation frame calls or callback, it will pass the time. We're going to simply check that the time is whatever the new time minus the old time should be greater than or equal to the interval. In our case, it's going to be 158. You can set it whatever value you want. And then update the last ones to the current time, so that the next time it will take care of it. Now if you see it, Just a minute. Oh, sorry. Now if you can, you are actually controlling the movement of the user, the runner. Next is to make the runner jump. Simply you're going to copy it. The only change that we are going to do is to change the position. Make use of the second row in the sprite sheet. That's all. For which we already have the coordinates in place. The same logic we will use. It has its own index, which is jump position index, and then refer to the array of coordinates, jump coordinates. So whenever the player is jumping up to create the illusion of jump, give the height, let's say -20, and then he obviously moves forward, so that from left, let's say +10. Let's see what we have. So basically I'm pressing the up arrow. So if you want to know the specific, here is the event handler that we have. So whenever you press up arrow on every key down event, we are setting jumping to 2. It's a simple if else we are having. So based on the value of the jump, it will call either jump or run. So whenever I press it, it will call jump. It will be run. So now the final thing that we are going to do is to have some obstacle in the way of the player so that he can jump over it. Simple. Maybe we can draw a bomb, something like that. So bomb image. Let's put it again in at 350. We don't have two bombs. At 450. You can actually scale the image. So the image is obviously very big. If you want to scale it, you can do it. Let's say canvas dot height minus the height of the image and then let's say we want to restrict the height and width to 50 pixels. Okay. It's not the height. Just let me quickly go to yeah. So something like this. And if you actually want to make the user die, you just need to keep track of the bomb position, and then if the question hits the user, you'll have to just kill him. That's all. It's all part of the JavaScript logic you're going to write. Okay. Any questions in this?
So everything is maintained through context object.
Yeah. Everything, as in, so it provides only the API part of it. So the objects, positions, what we are going to write or put in the image, the canvas, should be stored in the JavaScript terminal. That's it.
So mental frameworks around writing HTML games provide
Yeah.
the ability to manage that.
Everything, yeah. So even Canvas has so many libraries available. So this is we're trying to understand how it works, the low level of it. Even Canvas has many higher level APIs, libraries available. I mean, yeah.
How do you integrate sound into it, like sound effects?
So basically, Canvas. I mean, if you take HTML5 itself, there are objects like video, audio. It's not even part of the Canvas API. So it is out of Canvas. It is available within the HTML5 specification. You can make use of it. It's all playing on orchestrating things using JavaScript. So any questions? I think I'm done.
So what is the save do?
Okay, so like I told you, so if let's say we are not having this restore, not saving it. Let's see what happens now. You see here. So it will basically, we categorized our objects into different layers to create the parallax solution, right? So to make that work, we're going to use save the context and then move the canvas backward, restore it, so that every other layer can reform with their own coordinates. Anything else?
In this game, we are like recursively just drawing the layers at each point.
Yeah.
Right? Isn't it enough to just redraw the layer at each instant and not all the trees and the layers?
You have to make the trees move, right? Anyway, so of course there are some additional techniques available to avoid redrawing the entire canvas by itself. There are things like clipping, blitting, additional techniques available, but you have to go deep into it.
But for moving all the layers, we are just like he said, we're just patting the camera. So redrawing, is it the same thing as shifting the focus of the picture, or at each instant? If you redraw it, does it mean that it's shifting the camera, or is it like redrawing the trees itself?
So you're just rendering the tree at a different position. That's all you're going to do. That's what redrawing itself. There are so APIs available to clip. For example, if I want to update, let's say it's a very simple game, right? So we are going to have some thousands of objects in it. At every time, every frame, so there is not enough performance available in the system to update all of it, redraw all of it. You can clip it. When you clip it, you can restrict the position to this object and then redraw only that portion alone. That's called clipping. So there are so many techniques available to improve the performance. But again, we'll have to go deep into that.
So will it support all the resolutions?
Sorry?
Will it support all the resolutions?
No. So it's not a vector image. If it is a vector image, of course it will support. It's a bitmap, so if you zoom it, and it will not. You will have to handle it.
The possibility of introducing an automatic playing agent, for example, creating a table in an environment for the player, and there is a table environment is automatically.
So whatever Canvas provides you, it's kind of a platform, a low level API. So whatever you want to build, you can build anything on top of it with your own logic, anything. Even you can have your own event handling mechanism. Everything can be done, but you have to build it on top of it. That's all. Anything else? Any questions? Thanks.